look at our schedule. I printed new ones because we've had 2 changes now. 2 snow days. Okay, so basically, I just bumped everything. I bumped 5 and 6 to just be a day later than they were scheduled to be, so that we can still have Quest 1 covering lessons 1 through 5 without smushing any of the first material, right? Because I just didn't want to have things rushed going into the first quest. So then to catch up, what I did is after Quest 1, I took 7, 8, and 9, and I smushed them into 2 days. Okay, so on the 20th, we're going to do 7 and a little of 8, and then on the 23rd, we'll finish 8 and do 9. Okay, so we're going to do 3 classes in 2 days to get caught up. And then on the 25th, we had this catch-up day scheduled. It's still going to be a catch-up day, so that is kind of like a little breathing room for having to squish those 3 classes into 2 days. So we can take questions on that day about anything that's still confusing. And then we have Quest 2 come up right after that, which covers lessons 6 through 9. So then everything is back to normal. Okay, then everything is back on schedule. So this is your new syllabus calendar. Keep this somewhere. I updated due dates in my math lab. The homework that was supposed to be due today is still due today, right? Because we covered class 4 on Friday. So you absolutely could have done that homework and gotten it done for today. Well, it's due tonight at midnight. So you have the rest of the day to finish it also. But then everything after 4, 5, 6, 7, 8, and 9 all have new due dates that are pushed a little bit. Okay, so you can just look in my math lab to see those new due dates. All right, so in this lesson, we define the slope of a line. You may or may not have heard the word slope before, okay? So we're going to introduce it today. We're going to be talking about slope for the next several classes. We're going to see several ways to calculate slope. All right, so a portion of a road, road A, it climbs steadily for 120 feet. So it goes up by 120 feet, increase of elevation, over a horizontal distance of 4,250 feet. Okay, so here's a little picture of road A. Over a horizontal distance of 4,250 feet, we climbed 120 feet. Okay. And then a portion of road B, it climbs steadily 95 feet, goes up by 95 feet, over a horizontal distance of 2,875 feet. So note that those 2 diagrams are wildly not to scale, right? I have 120 looking almost the same as 4,250. So they're completely not to scale. But they demonstrate sort of what's happening. There's a horizontal distance and a vertical distance that this road changed by. All right, so we're going to calculate the steepness of each of those lines, right? So the greater the vertical change over a smaller horizontal change creates a steeper road. So you calculate the steepness of a line by looking at a ratio where you compare the vertical change to the horizontal change. So for A, we moved 120 feet vertically. So you always put vertical on top. Compared to 4,250 feet, we moved horizontally, and that comes out to approximately 0.028. So this is just a way that we can measure steepness. We compare vertical change to horizontal change in a ratio. So let's look at the steepness of road B. Okay, what's my vertical change for road B? 95, so that goes on top. Vertical is always on top. And my horizontal, 2875. And we put that in the calculator. How would you type that into a calculator? Divided by, right? A fraction bar is just a division symbol. So we pull up a calculator. Yeah, it's 0.033. I'm just going to demonstrate 95 divided by 2,870. Thank you. And we get 0.033. You might notice that that little squiggly, that equal sign is kind of squiggly. That means approximately equal to. And I wrote approximately equal to because I rounded this number, right? It's not exactly equal to that because that's the rounded value. All right, so now you can compare the two numbers, 0.028 and 0.033, and those numbers calculate steepness. Which number is bigger? B. B is the bigger number, so B is the steeper road. Okay. So it's kind of why I drew these not to scale, because so that you wouldn't be able to tell visually which one was steeper, you had to use the numbers. Okay, so 0.033 is a larger number, so it's a steeper road. So we'll write a complete sentence. It should include both steepness numbers in it. So I'll say, since the steepness of B, 0.033, is greater than the steepness of A, 0.028, road B is steeper. Okay, so there's my sentence. So to measure the steepness, another word for steepness is slope. To measure the steepness of a non-vertical line, you use a ratio that measures the vertical change in y coordinates compared to the horizontal change, which is measured by x coordinates. And we often call vertical change rise. How much did the road rise vertically? Compared to the horizontal change, which we often called the run. How much did it change horizontally? How much did it run horizontally? A shorthand notation that defines slope uses the symbol delta, that little triangle, it's delta. Which often represents change in. If you take a physics course or chemistry course, math courses after this often will use that symbol delta to represent change. Okay. And we also use M to stand for slope. So we get tons of new notation that I just introduced. Okay. So here are all the ways that we can think about slope. Slope, we often use the letter M to represent it. So slope equals M, which is equal to the change in the y coordinates divided by the change in the x coordinates. And change in y coordinates is just a vertical distance, which we represent as change in y, delta y, change in y. Change in the x coordinates, or delta x, which we also sometimes use shorthand rise over run. Vertical change over horizontal change. All right. So let's do an example, kind of give this some concreteness. In a previous class, we graphed this equation, negative 200x plus 800, y equals negative 200x plus 800, and it showed the altitude y of a hot air balloon measured in feet, x minutes after releasing air from the balloon. And we talked about it in one of the activities. So first, I'm going to pick any 2 points on the line. So I've picked 2 for you, but you can pick any 2 you want, right? So I picked this one, which is the point 0, 800. And then I picked another point where it just crosses at a nice grid point so I could tell what the coordinates were. And that point is 3, 200. And now I'm going to use the formula to calculate the slope of the line. So I have to figure out how much did it change vertically compared to how much did it change horizontally to get from one point to the other. So to get from here to here, picture this as a road, right? Yeah, so what is this vertical change?
600.
How'd you get that?
800 subtraction.
Yep, the 800 minus the 200. The change in the y coordinates tells you how much it changed vertically. So you can see on the y-axis, this point is labeled 200. This point is labeled 800. The difference between them is 600. And then what's this horizontal change? This distance here is 3. It went from 0 to 3. So that is 3. So the change in the y coordinates is 600. Change in the x coordinates is 3. But it's why is it negative 3? 0 minus 3, yeah, because if you did the 800 minus the 200, you have to do the subtraction in the same order with the x coordinates. So if you did 800 minus 200, you have to do 0 minus 3. And the order actually doesn't matter. Like I could have done 200 minus 800 and 3 minus 0, as long as you do it the same for both coordinates. So that comes out to negative 200. Okay. Why do you think I got a negative number for the steepness of this line? Because it's decreasing. It's like you're going downhill this time. So you get a negative number that measures the steepness. Yeah. Okay, I'm going to give you like 2 or 3 minutes. I want you to pick any 2 points in the line, but not the same 2 I just picked. Pick 2 different points and calculate the slope. Okay, so we've got our line. I want to pick 2 points other than the first 2 I picked. So maybe this one. What are the coordinates of that point?
1 and 600.
1 and 600. And then another place where it crosses and a nice grid point would be right there. And what are the coordinates of that point?
400 and 2.
2 comma 400. Good. So I have 1 comma 600 and 2 comma 400. So those are my 2 points. Next page, calculate the slope of the line using those 2 points. Okay, so how much do the y coordinates change from 600 to 400? What's the change there? 200. So if you do 600 minus 400, gets you 200, right? And then the change in the x coordinates, if I did 600 minus 400, if I subtracted in that order for the y's, I have to do the same order for the x's. So what's my subtraction for the x? Negative 1. I should do 1 minus 2, right? Because I did this point minus this point. I have to stick with that order for both coordinates. So 1 minus 2 is going to be on the bottom. 1 minus 2, which is negative 1. 200 divided by negative 1 is negative 200. So it does not matter which 2 points you pick on a line. When you calculate the slope, you always get the same number. You always get the same value for the steepness. So hopefully you all got negative 200 as the slope. Doesn't matter what 2 points you pick. You should always get the same slope.
The angles remain the same.
Because the angle is remaining the same. The steepness of the climb is always the same, or the descent if it's negative.
If you change the angle, then you get a different number.
Correct. Yeah. So in this, let's think about what the slope means in this situation. So let's write down the units. So last class we talked a lot about unit analysis. We're going to do it a little bit right now. So when I did my first calculation, I did 800 minus 200 and I got 600 feet, right? And I got negative 3. That was, how did I get negative 3? I did 0 minus 3. Those were minutes because that was on the t-axis. So I have 600 feet divided by negative 3 minutes. So I end up with negative 200. That's the 600 over the negative 3 feet per minute. Okay. So once we've written down the units, it's fairly straightforward to write a sentence in plain English that explains the significance of the slope. Right. So this is a balloon descending, right? That's why the slope is negative, because it's coming down. Right? And we would say, here's a good sentence. The balloon's altitude was changing by negative 200 feet per minute. A better sentence would be to say the balloon's altitude was decreasing at 200 feet per minute. So note that I translated that negative sign to the word decreasing, right? To translate from the mathematical symbol to a plain English word. That negative sign means a decrease. I don't do both. You don't write decreasing at negative 200 feet per minute. That's like using a double negative in an English sentence, right, which actually reverses your meaning. You guys know what I mean by a double negative in a sentence?
Yeah.
Can someone give me an example? I don't not work, which means I work. right? So you don't use the negative sign and the decreasing, because then you've got a double negative. All right, the best would be to say the balloon was falling at 200 feet per minute, right? Because falling is just a little bit more plain English than decreasing, right? So you want to interpret this so that you could explain it to somebody, tell somebody what that negative 200 means, who's like not in this class. That negative 200 means the balloon is falling 200 feet every minute. All right, there's a couple of common pitfalls when you are calculating slope that you're going to want to avoid. Slope is change in y over the change in x. So vertical always goes on top, horizontal always goes in the bottom. It's very easy to reverse it to sort of forget which one goes on the top and the bottom. You need to be consistent in the order that you subtract the numerator and the denominator. You can do either direction, but you just have to do both coordinates in the same direction. Okay. So if I want to do 0, 800, and 3, 200. If I do the 800 minus the 200, so if I do 0.1 minus 0.2, I have to do the same direction for the x coordinates. I have to do 0 minus 3. Right? Or I could do it in the other order. I could do the 200 minus the 800 on top. That just means I have to do 3 minus 0 on the bottom. Right? If I do 200 minus 800, I have to do the 3 minus 0. Same order for the x's as for the y's. They both come out, both of these, reduced to negative 200. Because this one, the numerator is positive and the denominator is negative, so you end up with a negative. In this one, the numerator is negative 600, but the denominator is positive 3, so it still comes out to negative 200. Right, so you can do it in either order, you just have to be consistent. You cannot do 800 minus 200 over 3 minus 0, right, where you do the x's and the y's in the opposite order.
Positive number instead of a negative.
Because then you would end up with a positive number and you lose the fact that the balloon is decreasing. That would mean that the balloon's altitude is going up. All right, any questions before you start the activities? All right.